Hello everyone, EcoTech here, and in this video I'll run you through some numbers of the EcoTech lights. If you're interested in the lights, please check the description. There's a link to my new website where I am gathering emails for early bird coupons, as this will soon enter Indiegogo. So I've been running the grow light to run some hydroponics in addition to a few microgreens. You can see that my hydroponics are doing fairly okay. The root system is doing well. It could be better, but they're doing just fine. You can see my peppers and I have a few strawberries in the back and a lot of basil and some nice mint, tasty mint. Yeah, so if we go back to the grow lights, the setup that I have here is I connected my power supply to a kilowatt, and you can see that right now we're pulling 78 watts roughly. If we follow the power cord, it'll go to this mean well driver, which is outputting 68 watts to the ribbon cable, which is connected to this shelf. And what I did is previously I've set the intensity of the power supply such that on my lux meter I would be reading 3,300 lumens. And why 3,300 lumens? Well, if you took this lux meter, sorry for it's adjusting the brightness. If you put this lux meter on this shelf between the two Barina lights, you would get 3,300 lumens. So when I took some power measurements, let's check the board over here, at 3,300 lumens on the LED bars, the power supply was pulling 21.7 watts from the wall, and there was 16.2 watts on the ribbon cable. So this gives us an efficiency of 74% on the power supply, and at 3,300 lumens we're getting about 66 micromoles per second. So this is on the fairly low end in terms of not only power but efficiency. However, when we compare it to the Barina was pulling 39.1 watts out of the wall. So we can see that already we're 180% more efficient than the Barina. However, the mean well power supply used in this setup is not meant for 22 watts, let alone a bit lower. It's meant for much higher. It's meant for 300 watts, I believe. And so when I increased the power of the shelf and I increased it to 82 watts out of the wall, which is 70 watts give or take on the ribbon cable, the efficiency of the power supply went up as it's closer to its intended power usage. And you can see that I was outputting 240 micromoles per second on this shelf, which is closer to an ideal micromole per second level. So I'm fairly happy with how the efficiency is turning out on this mean well driver. I still have this driver to test out over here. There's another mean well driver, a 240 watt, that I'll try. And there's a cheap power supply that's available on Amazon, and basically I'll take a few measurements and compare the efficiencies and try to pick the best. But there's already this power supply is right now my favorite for a few reasons. One, it's the interface is pretty easy with my, well, easy as in I can make it cheap. I can make a low cost adapter that interfaces here. And not only that, this unit is rated for 100% humidity without the use of a fan. So it's fully sealed, fully potted. It is water resistant, so it's splash resistant. However, this other power supply that I've been running, although might have a bit higher efficiency, it has a fan that's right now fairly loud. So let me turn this fan off. And it's not as water resistant, so it's not ideal. And on the other hand, this driver is probably the most efficient, but connecting and interfacing this is a bit of more of a hassle. It's not as user friendly, and it might add a bit of cost. And I'm trying to lower costs so that everyone can basically grow for cheaper without compromising on the quality of the light. So I've taken a lot of decisions to try and put the money on the quality of the light, which is the LEDs. And there's a few things that maybe I could have spared the expense, such as these magnets, but being able to just remove the light and put it back together, even one-handed, and just adjust it to the position you want, that I really find that enjoyable compared to adding the zip ties or the wires and whatnot, the hassle that comes with the Barinas. So there you go, a small overview on the numbers, a small preview of the numbers, the tests that I'm doing here. I hope to one day get a proper power meter to get better measurements, but in the meantime I'm using Micro's conversion chart and using the lux meter, well, the lumens, yeah, taking lumens and converting them to micromoles. The website is up for, if you're interested in these lights. I'm taking down emails, and whoever signs up will get a early bird discount. Currently working with a few people to try and get an Indiegogo campaign started, because although I could order the first 500 LED boards on my own, it would be better to raise more money and order 1,000 LED boards, such that the overall cost drops, the production cost drops, and everyone gets the light at a cheaper rate. So if you're interested, please sign up. It'll really help me, and once the Indiegogo campaign is out, I really hope that some people are interested, I guess, as I'm planning to make a career out of this. Thank you. Bye.